We have seen the examples for electric dipole moment, electric dipoles, water, ammonia, carbon dioxide, chloroform. Idella examples for electric dipoles. In all these examples, why these are taken as very good examples for electric dipoles? In all those molecules, the centers of gravity of the positive and negative charges, they are separated by a very small distance. They will not coincide. The center of gravity of the positive and negative charges do not coincide. So, this we call it as the electric dipole. So, here all this will have permanent electric dipole moment. All this will have permanent electric dipole moment. How I can define? The centers of gravity of the positive and negative charges do not coincide. That is why these are taken as very good examples for electric dipoles. Then we will see what happens if an electric dipole is placed in the electric field. Now, we will see how will be the electric field due to a dipole at a point on its axial line. Now, we will see due to this dipole, we will see on its axial line how will be this electric field. Now, we know what is meant by dipole. Dipole line. Dipole means two equal and opposite charges. They should be separated by a very small distance. Now, let A, B, here I have 2 points. At these 2 points I have 2 charges. One is minus Q, the other one is plus Q. These two are separated by a distance 2D. What is 2D here? Distance of separation between these two charges minus Q and plus Q. Now, I will just take this is the axial line. So, for this dipole AB, AB is a dipole where minus Q is placed at A and plus Q is placed at B, and this B is its axial line. I have a point P. Let O be the center of the dipole. What is O here? Center of the dipole. Let P be a point which is at a distance of R from the center of the dipole. Here, what is 2D? Distance of separation between the dipole, between the two charges. Now, if this is 2D, what is this distance? D. This is D. Now, we will see separately due to these two charges minus Q and plus Q, how will be the electric field? Now, due to the charge plus Q, first I will see how will be the electric field. I will take that as E1. What is E1? E1 is the electric field at the point P due to this charge plus Q. What is E1? E1 is the electric field at the point P due to this charge plus Q, which is placed at B. It is given by the formula E1 equal to 1 by 4 pi epsilon naught Q by R square. Now, I want to find out what is the distance of separation between this charge Q and this point P. That is, I want to find out this distance. So, total is R. I want to subtract this. Then only I can find out the distance BP, isn't it? So, how to find out this? This is BP square. I want to find out what is the distance BP square. I can write this as R minus D, isn't it? R, total is R. You minus this distance, I will get the distance BP. So, here I can write BP square is nothing but R minus D the whole square. Then, I want to say in which direction this electric field is acting. It will be acting along, since it is a positive charge, we already seen this electric field will be pointing away. So, this electric field due to the charge plus Q will be acting along BP. This is the direction of the electric field. So, here let E1 be the electric field due to the charge plus Q placed at B. Similarly, I can also find out how will be this electric field due to the charge minus q placed A. I will take that electric field as E2. E2 equal to 1 by 4 pi epsilon naught. So, these two charges are equal in magnitude. I can say simply QQ. Now, from here to here I want to calculate what is the distance. From A to P. From O to P this is R. So, this is D. So, the total is R plus D. So, here I can the distance between A, that is a charge minus q is placed at A to P, it is given by R plus D the whole square. Can you say the direction in which this electric field E2 is acting? If it is a positive charge, it is pointing away. If it is a negative, it will be pointing towards it. So, I can write this as this electric field, it will be acting along PA. This will be the direction of the electric field. Now, we have calculated separately how will be this electric field due to the two charges Q1 and Q plus Q and minus Q. So, I want to find out the net charge. I want to find out the net electric field due to the two charges. So, it will be always equal to the one charge minus another charge. Which charge is having greater magnitude minus the another charge. Here, positive will be having the greater magnitude. So, I can write this the net electric field due to this dipole is given by E1 plus minus E2. Just wait a minute, shall I rub this? Because I thought I can finish up to this 10 more. Then I can stop with this. Okay, I will finish up this derivation. Now, I will find out the resultant electric field due to this dipole. It is given by E1 plus of minus E2. Because if you see the direction of the electric field, E1 will be acting in this direction and E2 is along PA. It is along BP, it is along PA. Both will be acting in the opposite direction. So, how to find out the direction of the resultant electric field? At this direction, that is the resultant electric field direction, will be in the direction of the electric field or of the charge which is having greater magnitude. எந்த சார்ஜுக்கு greater magnitude இருக்கோ அந்த டைரக்ஷன்ல தான் ரிசல்டன்ட் எலக்ட்ரிக் ஃபீல்ட் அதிகம் ஆக்ட் பண்ணும். ஃபார் எக்ஸாம்பிள் ஈவன் உடைய எலக்ட்ரிக் ஃபீல்ட் சார்ஜுக்கு வந்து கிரேட்டர் மேக்னிடியூட் இருந்ததுன்னா ஈவன் எந்த டைரக்ஷன்ல இருக்கோ அதே டைரக்ஷன்ல தான் ரிசல்டன்ட் எலக்ட்ரிக் ஃபீல்ட் ஆக்ட் பண்ணும். ஸோ ஐ கேன் ஈஸிலி ஃபைண்ட் அவுட் E equal to E1 minus E2. So it is given by E1 E2. So what is the common இருக்கிறது? You just take it out. 1 by 4 pi epsilon naught. Q also I can take it out. 1 by R minus D the whole square minus 1 by R plus D the whole square. Now, we will solve this. It is given by Q by 4 pi epsilon naught. So, this is, if it is A plus B into A minus B, it is A square minus B square. So, what is A plus B into A minus B? It is A square minus B square. So, here I have A plus B the whole square into A minus B the whole square, here again the whole square. So, I can write this denominator as R square minus D square the whole square. Then you cross multiply these two, here R plus D the whole square minus R minus D the whole square. Again you simplify this, it is given by Q by 4 pi epsilon naught. Here we expand these two in the form of A plus B the whole square. A plus B the whole square equal to A square plus B square plus 2AB. Then here minus A square plus B square minus 2AB by R square minus D square the whole square. Now again we expand this. This Q by 4 pi epsilon naught. So in the denominator I have R square minus D square the whole square. Here if you remove this bracket, take the minus inside. So in the numerator I have R square plus D square plus 2RD minus R square minus D square plus 2RD. So this gets cancelled, R square and D square. So what is the remaining? I will be getting 2RD plus 2RD. It is nothing but 4RD. Q by 4 pi epsilon naught 4RD by R square minus D square the whole square. Now we have seen in this electric dipole AB, this point P is at a distance of R from the center, but this distance is D. If this point P lies far away from the dipole, if this point P lies far away from the dipole, when compared to this distance R, this D will be very less. So when the point P is very far, point P is very far away from the dipole, at that I can say D is the distance D is very less when compared to this R. D distance will, because the 2D itself is very less. Half of it will become very less when compared to the distance R. So I can neglect this D square when compared to this R square. So what happens if you bring this change in that equation? It will become Q by 4 pi epsilon naught into 4RD by, this gets cancelled. So R square into R square, it will become R power 4. 1R gets cancelled. So remaining is Q by 4 pi epsilon naught 4D by R cube. Again I can also write this as Q 4, I can write it as 2 into 2D, 2 into 2 by 4 pi epsilon naught R cube. This Q into 2D, which is nothing but your electric dipole moment, Q into 2D. So in the place of Q into 2D, I can write 2P by 4 pi epsilon naught R cube. This gives you the resultant electric field at a point P on its axial line due to the dipole AB. So this will be the electric field intensity along the axial line of a dipole at a point P. Now can you see the direction of this? E equal to 2B by 4 pi epsilon naught R cube. It will be along BP. The direction of this will be along BP. So it's a very important question. So we have found out, we have seen how will be the electric field at a point on its axial line due to a dipole. This is given by 2P by 4 pi epsilon naught R cube.